Hello and welcome. This is Gabriel, co-founder of Cassandra. Today we're going to do something special. Today we're going to do a complete marketing mix modeling project with real data from scratch using Cassandra MMM Builder. So you can understand and receive all your marketing mix modeling insights from this analysis, and especially you can create your own budget allocator so you can simulate how to distribute your media investments, predicting the incremental impact of on sales of this decision. Now, first thing we need to do is we need to go to our dataset. Obviously, the dataset is the most important thing in a marketing mix modeling project, and it needs to be set up in this way. You need to have, in the first column, your date variable that needs to be set up with year, month, and day. You can aggregate each row per week or daily or even monthly, but it needs to have all three variables inside: day, month, and year. Now, second column needs to be the output variable. It can be both app installs, transactions, conversions, leads, or new customers or orders. Then what we need to do is we need to import the expenditure, so how much we invested in each campaign type, aggregated weekly or daily. In this case, we're doing weekly. So we have Google Search Brand, Google Search No Brand, Google Display Spend, Google Performance Max, Google Facebook Others, etc. You can check here that we inserted also impressions. It's not important. You can avoid exporting impressions. They're not used inside of the modeling phase. It's important to have a dataset with values inside. So if there is this non-value, please keep in mind to fulfill it with the real value. Obviously, there's not only the digital media investments, there is also the offline investments, which can be influencer spend, podcast, and so on. And these variables especially are what you need to do is you need to import in the week in which you invested for influencer spend. You need to input it there. Same thing for the podcast spend, and same thing. Based on this variable, he's gonna measure the impact over time of these investments. Other than that, we have organic variables, which are Google Search Console impressions, session from social, session from direct, session from emails, and so on. When creating your dataset, keep in mind that you want to insert all the variable as a media investment variable or as a session or scalar variable that might, when you're creating your dataset, keep in mind to insert all the variables that might influence your sales. Because the idea here is to create a dataset that enables you to test hypotheses. So you have a list of assumptions that you have in your marketing mix. You insert everything. I think that all these variables have high impact in my sales. So I insert everything. Once I've inserted everything, I'm gonna use this dataset to insert it in Cassandra and model it and validate whether I'm right or I'm wrong. Now, taking this, what we're going to do now is to go and start an exploration analysis. What we need to do is we need to create a graph, a simple time series graph, in which we're gonna input in the x-axis date of the week, and in the y-axis we're gonna put transaction conversions and all the media variables. So let's say we want to go to personalize, and obviously we want we go on series, and we want transactions on the right axis. So it's balanced with all the values. And let's see transactions here. There it is. It's in red. And in here we can see all the variables and how much you spent each week on each of these media factors. The first thing I see is that here, Facebook Others, which is in orange, has not a lot of expenditure, which means cannot affect much number of sales. So I'm gonna avoid when modeling to insert this variable in the media variable. Then there is this pink spend, which doesn't have a lot of expenditure, but it's increasing, so I'll keep it. And all my data seems consistent with my historical data. There are non-values, or there is everything. There needs to be consistency in the past data. Let's go to the organic variable. We're gonna do this exact same thing. We're gonna copy it and then insert just transactions and organic variable, which in this case are S social, S email, and S direct, which S stands for session. Now we can see first two things really easily. S direct has an anomaly here, which this variation of direct sessions does not explain anything in the transactions. In fact, there has been a downward slope in the transaction when there has been a positive spike on number of sessions from direct. Then we're going to see what's the correlation between these two factors. The most correlative feature I see is S-email, which is in yellow. And then, And then we're going to see the S-social has a lot of variance, which it seems interesting. Let's see what happens. Good. Right now, what we want to do is we want to export this model, this CSV file. Awesome. Let's save it. And then let's go to Cassandra, right? So what we want to do is we want to insert our dataset. We just drag and drop it. We have all our dataset, as we saw. First thing we need to define is the decimal separator, which defines what's the decimal separator for your dataset. In this case, it's dot. Let's call it test. Well, it's going to be test. Let's define the date variable, the output variable, and the output variable type. Now, in media columns, we need to insert just the media columns. So they're already taking all the spend variable. I want to avoid inserting Facebook others. Organic columns, it's as social, as direct, and that's it. I don't have any context columns. Context columns, generally speaking, are non-scalar values. So they're all the features that have Boolean values or a list of defined input metrics, which can be from 0 to 4, 0 to 10, but it doesn't need to be exponential like the investments on Facebook, for example. Let's go forward. Let's define the window, the modeling window, and the modeling window allows you to define what's the period in which you want to model and train your model on. Important fact is if your business has been affected a lot by COVID, just take a model in a rolling window that's after the COVID. In this case, the seasonality is from Sweden. Let's model seasonality and holidays. I want to model 10 times 5. So I'm gonna create 50,000 models. It's gonna iterate for 50 times in order to find the best values. Let's hit next. We can see a little check on all the inputs we inputted. Everything looks fine. Perfect. Now we need to go to the trickiest part of all. We need to define what are the upper parameters for Adstock and Diminishing returns. The first iteration is going to be done by the AI. So what it's going to do here with this button is going to try all different upper parameters that maximize the correlation between the transform media variable and the output metric. So let's see what's the output. All right. So we have Bing. That's instant impact on Bing. The average spending, this is the diminishing returns curve, which looks like a little too much linear. So let's model a little bit. Let's reduce alpha to 1. All right, makes sense. Now, display, we need to check every factors in our marketing mix. Sometimes it can seem that this curve is too exponential. So we want to modify alpha and we want to put it at 1 to make it more linear like, as we can see. If we want to make it more saturated, we reduce gamma to 0.5. Let's reload it. All right, now it makes way more sense. Display is a longer effect, so we want to change scale to 0.1. Let's see what happens. All right, this is the delayed effect of display. Let's move Facebook conversions. Obviously, let's move the scale to 0.5. All right, and we want to reduce the alpha. Alpha 0.8 makes sense. Awesome. Let's move again all the alphas because in this case, do not make physical sense to do that. So let's move scale. I'll continue for all the media variable that I have active with this format. So we defined all the upper parameters for each campaign type, in which on the left we have the diminishing returns, which describe the marginal utility of investing more money on that particular campaign type. And on the right side, we have the Adstock, which describes the effect over time of an investment. And in here, it can be explained really easily. So display spend, for example, has average delayed effect of 1 week. This means when doing adjustments in your campaign, you should wait at least 1 week to see the effect on your conversions. And describes what's the delayed effect of my investments on my sales. So let's go forward. Next. Awesome. The model is ready to be trained. Let's train. Awesome. What we need to do now is to train our model. So let's click train model. It's going to search for an instance to train our model on, and then it's going to connect with it. And then we need to click one button and all right, let's train our model. Started training. All right. So training started. Saving output, the running trials, everything is good. Let's refresh this page and check the status of our modeling. So we check status. Awesome. running trial. It's at 8% of the first trial. Awesome. Super happy to do it. So we check status, we click here, and we're gonna see actually whether it's running. Awesome, we are at 12% of the first trial. I'm super happy. Let's come back when all the training has been done. Once the model is started, it's gonna take more or less 1 hour to train. After it's finished, what we're gonna see is that our model is gonna change status into models ready. We're gonna click select model, and we're gonna see the Pareto efficient output of the best 5 models. The output is gonna be between 3 and 10, or less. The less they are, the better it is. And what we're gonna see here is the list of the best models splitted by, measured by R-square, MAPE, Decompare SSD, and RMSE. So first thing, you evaluate and you decide what model to choose based on 2 metrics. Decompare SSD and NRMSE. Both needs to have the lowest possible value. So what we see here is 4.49 and 23, 5.78 and 10, 5.97 and 10. These may be widths. Let's see and check this model. Awesome. First graph that we see is a time series in which we can see the predicted orders and the actual order that we got historically in our dataset, in our rolling window that we set before. Second thing that we see is the decomposition waterfall that shows us what's the impact, what has been the impact of each variable on the sales that we generated historically. And in this case, we have the maximum impact is attributed to Google Performance Max and Google Search Now Brand. And then we have all the rest and all the other features that influence sales. Then what we see here is ROAS effect, share of spend, and cost per conversion. In here, we have an average cost per conversion of around €250. And in here, we can see what are the cost per conversion per each campaign type we have active in our marketing mix. We can check what are the diminishing returns curve. Like in this case, we have the Facebook product catalog sales has the best response. We're going to eliminate it. Oh no, it was session direct. Sorry. Then we have in the yellow Pinterest. Sounds like it's working really well, but we don't want to see it. And then there is third is session emails. I'm gonna delete those 2. Let's see, Bing works really well, and so on. You can measure every diminishing returns curve. After the diminishing returns, you can see and check what is the effect over time of each variable that we inputted. Like for example, there's gonna be an explanation that tells you exactly display investments have an average delayed effect of 1 week. This means when doing adjustments to the campaigns, you should wait at least 1 week to see the effects on the conversions. Same thing for each factor we input in our market. And we can consider everything. Like, for example, podcast has a higher delayed effect of 3 weeks according to this model, which makes sense because people that actually read and actually listen to the podcast don't happen the same day. They happen over time. And probably the maximum impact is in the first 3 weeks. We can check and decide also other models like this one. Let's check this model, which shows an average similar. Google Search has a higher cost per conversion according to this model, and the Adstock effects are really similar. What we can see is 3 weeks for podcasts. Yes, it's really, really similar. But in this time, Facebook per catalog sales got the most impact and not Google Performance Max, probably because there has been multi-collinearity inside. But what we want to do is we want to choose, I believe that, let's check here, Google Performance Max. And this model describes better how my model works. So I'm going to click Save. What we see here is the same graph that we saw before. There are the cost per conversion split up here. So the attribution of the cost per conversion graphs. Same waterfall decomposition here. We can check the share of spend, the share of effect, and the CPO by each campaign type we have active in our marketing mix. And this is one of the most important part in our marketing mix. In this decomposition over time per week, we aggregate everything on a weekly basis. And in this weekly basis, we have analysis that tells us why we got positive spikes and downward spike over time. We diagnose what were the factors that influence sales to generate positive spikes or downward spike. In particular, in this case, we have seasonality that influence sales by a lot. Then there is Bing in this period that influenced by a lot. But then we increase budget on Facebook conversions. We increase that on Google Search Brand and so on. And these factors, more or less, mostly Facebook conversions, being and seasonality are the driving factor that generated this positive spike here. It's really, really good tool to understand how many conversions came from each factor. In this case, in this week, from Facebook conversion, we generated 218 sales. Obviously, in here, you can split and delete all the factors and isolate each variable and understand how many sales it generated. Like in this case, influencer is interesting because if we go and isolate influencers, you can see the positive spikes and how many. Look at that. 15 August, we generated 120 sales, then 110, and then 114, and then 5th of December, 103. And we can isolate historically how each factor influenced sales. And then here you have the spent over time per week, which you can see how the budget has been distributed over time over multiple campaign types. And in this case, for example, the podcast has seen an increase in expenditure that then has been moved to the week after. Said that, let's go to the budget allocator. All right, we are in the budget allocator. We need to just define a simulation name. So we want to do simulation. We want to invest 100K next week on advertising, and we want to predict next week of advertising. Let's click optimize budget. And what Cassandra is going to do is going to distribute all 100K across all the campaign types we have active in our marketing mix. And it's going to predict how many conversions we're going to generate from that investment. So let's see what it comes through. As we can see, it distributed 100K, which represent 14% less than the previous weeks, across all the campaign types we have active in our marketing mix. And it suggests us basically to reduce budget on display, reduce it on performance max because it was too hot, and reallocate it in influencer and podcast. If we take that decision, we predict to generate 313 sales at a 318 cost per conversions, which is 5% less than the previous 2 weeks. So what we have here, and here we can see what are going to be the cost per conversions split by campaign type in light blue, the optimal, the future cost per conversion. And in dark blue, we have the actual cost per conversions measured by Cassandra right now. So it's going to reduce the cost per conversion by a lot on Performance Max. It's going to reduce it on Influencer, etc., and so on. After that, maybe you want to understand what are the factors and how each factor in our marketing mix is influenced by each other in terms of effect over time and diminishing returns. What you want to do is you want to go to the channel discovery. In the channel discovery, you're going to see what are the factors and how each Adstock and diminishing returns are drawn and describe reality. In the Adstock and diminishing returns section, what you can see here is the effect, diminishing returns, which describes the marginal utility of investing on Google Display. While in the vertical axis, what you have here is the average expenditure. And in Google Display, as you can see, you are a little overspending. You should probably invest a little less on advertising, and you can see all the other factors that can influence sales, like Google Performance Max. Let's see it. And here we can see Google Performance Max diminishing returns and Adstock, and we can actually check the correlation that there can be between the investment variable and the output variable, which are the conversions and the transaction. So as we can see, there is a positive correlation of 39%, which is not really bad. There is only one outlier here, but the rest shows really nice correlation. With increasing the budget, we have an increase in conversions. And then we have at the end seasonality decomposition. And in seasonality decomposition, you can measure how much to increase your budget, marketing budget in high demand season. Like for example, November and December, you should increase it by 15%, while in August, that it is low demand season, you should decrease your marketing investments by 20%. Arbitraging on better times and arbitraging over time on seasonality and changing demand allows you to better allocate in a time series your investment and increase your overall ROAS of your investment. Said that, you've created all the models and all the data for a marketing mix modeling project. What I would do is use Budget Allocator to make decisions, to take decisions to the next level on my marketing budget allocation. And what I want to do is then analyze over time what are my performances based on this output, based on the decomposition over time per week. All right. Hope that this video explains all the outputs and all the insights and how you can transform these insights into practical decisions from this analysis. Right now, you can use it for free. There are no limitation. We're going to input limitation at the end of this week. We are in the 6th of March. Before the 10th of March, there's going to be limitation, but it's going to still allow you to create at least one model and use the budget allocator and run and analyze all this data automatically. Hope everything has been clear, and I'll wait for you. I can't wait to receive your feedback on your modeling.